Right, we have a problem with the Samsung Tab 3 T210, and the issue with it is basically it's got a fake charging situation where you've got the charging indicator and the battery percentage, but unfortunately the battery percentages keep on dropping. Although that the charging plug is plugged in, it's not actually charging the battery. So we're going to go through the troubleshooting process. I've got a circuit diagram. It's pretty easy, but very tiny IC that needs replacing, so I'll be going through that very shortly. Okay, so let's turn this device off. Okay, now while it turns itself off, I'll just quickly move on to the screen and have a look at the diagram. Okay, so that's the block diagram. The PCB, the second side bottom half of the PCB. Okay, and then we're looking for power or battery related issue, charge related issue. So we'll scroll down, and then there we go. It's charging part. Okay, so the USB is inserted, which it was. Do we have power? Well, charging sequences start at voltage in. V in stands for voltage in at 5 volt. We have that. Okay, so we're going to move down. Yes. Battery is charging. No, it's not charging. Okay, so resolder or replace U506 IC. So let's try and locate that now where it is. Okay, it's situated on the bottom half of the PCB. Now, this is where U506 is, just under the inductor L505. So let's move on to the, what I'm going to do now is I'm going to sort of dismantle the unit and take the PCB off the tab itself. Okay. It's okay. It's already been all the screws have been taken off already, so no, it's not a big deal. That can go there. Right, all the connectors going to come off. I'm going to use my hand. In fact, okay. Right, so that's all the connectors are off. Oops, no. One more. There we go. That can go back in the tray. Okay, the IC what we're referring to is on the actual PCB. Let me sort of switch this around. That's okay. Right, we're going to replace this. This is the IC what we're going to replace, but remember the orientation. The dot here and the dot on the IC should be matching when we replace it. Now the next step is I'm going to mask around the area, because what I don't want is anything else to be overheated and blowing off the circuit. So let's move on to that side. Sorry, you didn't see all that. Right, so I'm going to mask around that area. Okay. Tiny components, so you've got to be very careful with what you're doing with them. Some of the capacitors and the resistors is flipping barely noticeable. Okay, so even after doing that, I'm still going to use my reflective aluminium tape. It's always a good idea to mask around the PCB, so you're not sort of applying heat onto the, unnecessary heat onto the rest of the components basically. I mean, I do it. It's entirely up to yourself whether you do it or not. But I tend to sort of play safe. The reason why I'm putting these tapes around is what I don't want is applying a lot of heat, and then due to any sort of movements, those components underneath the PCB decides to sort of drop off. I'm going to be in a lot of crap. The PCBs are very thin PCB, so the heat is going to travel in around all the components very quickly. So I do not want to worry about losing any components underneath, so I'm pressing it down just so that the foil sort of holds it in place and it doesn't sort of loosens it. Right, okay, I'm going to move on to the next stage, which is likely to be under the microscope. Flux. So here we go. Here we go. So the piece of shit is off, and I don't know what I've done with it. I've dropped it somewhere. Okay, now it's be very gentle. Tiny pads, and the last thing you want to do is lift one of them and you've had it. You're blowing it basically, so be very careful with it. And apply a bit of flux. Sort of rest this. Right, okay, I'm going to apply a bit more flux with this. If I do that, I need to secure this IC. Okay, and I'm going to apply a bit of flux underneath the sure that it's enough there. Okay. Now remember, the orientation of the IC itself needs to be correct. So the dot is there. So the dot is there, and this is where it should sort of fit back in. I'm going to take this under the microscope just to sort of line up the IC. Right, I'm not going to do this under this microscope, but I'm going to have to do this under a bigger microscope, because I need to see the movement of the IC and I can barely see anything underneath it. So I do apologise, but You guys not going to be able to see that. It'll be a lot bigger and better microscope. So that's where it sits. It's back in here again. Remove this, put this microscope away. I would like to see it jump into 88%. That's when I will end the recording. Here we go. Guys, I don't know if you can see. Oh, horrible, horrible little monster. Right, okay. It's just jumped up to 88%. Just go back on here. And I fucking hate this light. Can you see that? 88%, just about. Please forgive me for. But there you go, 88%. Don't know why the screen's. Oh right, okay, I see what's happened here. There's a little dirt that's sort of not showing. There you go, 88%. Okay, so I'm going to leave that on charge for a little bit longer. Schematic was pretty straightforward. So it's a very sort of you know, I found it quite easy. The thing to remember with the IC is very, very, very small. So what you want to do is you want to make sure that when you're taking it off, that's absolutely fine. Make sure the surrounding components are covered, protected, so when you're applying a bit of a heat to it, you're not blowing components off the surface, off the PCB itself. The other thing to sort of bear in mind is also, you know, when you do put the IC back on, do not press on it. Just let it sort of sit by itself, and while during the reflow process and the solders are sort of liquidous, you know, the solder balls underneath the IC, don't please apply any pressure on the top of the IC. And what I did here is I minimized the airflow on my hot air station to about 5, maximum is 8. So I've reduced it from 8. 8 is when I was taking off the IC. Then I've reduced it to 5, just so that I'm not going to blow off the IC from the surface of the PCB, because it's very light, very small, and you know, you just don't want to blow it off the PCB itself. So hopefully this was you know, a good sort of a troubleshooting process, and you know, all the best and good luck with your repairs.